Good day to all of you. Today we shall discuss on Model Question Paper 1-2 with effect from 2023-24 CBCS scheme, third semester BE degree examination of the subject Object Oriented Programming with Java with the subject code BCS306A. So in this question number 1b, define array, write a Java program to implement the addition of two matrices that carries 7 marks. So first let us know what is array. Array is a linear data structure. Means the data elements in the memory will be stored in sequential manner in array data structure. Data structure in the sense the way in which the data is stored in memory. So linear in the sense it is stored in sequential manner. If we are able to access the first element, then very next element will be the second one. The very next element will be the third one. That is what is sequential order of storing. In case of array data structure, these memory locations will be in contiguous memory locations or consecutive memory locations. That is, if address of first memory location is 1000, the next one is 1001, 2, 3. That is what is consecutive memory locations. So such kind of storage of elements will be done in case of arrays. Array data elements will be stored in consecutive memory locations. Okay. So array is a linear data structure. Second one is static data structure. Means size once declared it cannot be changed. Neither increased nor decreased. So if array is declared to be of the size 5, means 5 consecutive memory locations will be reserved by one name. Whatever name we mention in the instruction, that will be array data structure. Size 5 means 5 consecutive memory locations will be there in that. It cannot be increased to 6 or any number. It cannot be decreased also, made less than 5. That is what is the meaning of static data structure. Next, it is homogeneous kind of data structure. Means it can store only one kind of data. If you declare it to be of int type or float type, then it can store only integer type or float type data respectively, not both, right? So matrix is implemented using two-dimensional array. So we have different kinds of array. It is single dimensional or multi-dimensional. Then we shall know what is single dimensional, multi-dimensional. Multi-dimensional, in that we are going to see two-dimensional. That is what is required for matrix implementation in any programming language, but here using programming language Java we are doing, right? So next we shall see what is single dimensional array and two dimensional array. Here consider array declaration. So it is going to store integer type of data, hence int reserved word we have used. Then array name we are giving a, size of array 6. So these are the 6 elements 1, 4, 2, 3, 6, 8. So within flower brackets semicolon, when equal to, when we write in the memory, 6 memory locations are reserved. Its name is A. They are reserved in the consecutive memory locations. Okay. Array data structure in the sense memory locations allocated will be in consecutive memory locations. That is another point. Size of array here taken is 6. Hence 6 consecutive memory locations are reserved. What is its name? A. What is it can store? Integer type of data 1, 4, 2, 3, 6, 8. So this is what line or instruction we call it as array initialization. Array initialization means at the time of declaration the values are assigned to the memory locations. Okay, which are the memory locations here? 6 memory locations. First memory location is A of 0, means its index is 0. Second memory location index, that is 1. Third memory location index is 2. Then 3, 4, 5. So 0 to 5 are the index of the 6 memory locations, which is an array that is called A. So all the 6 memory locations will be in contiguous memory locations, right? When we initialize this way, 1 will be stored in 0 indexed memory location, 4 will be stored in next where index is 1 in that memory location, 2 will be stored in where index is 2 here, 3 here, then 6 is stored in where index is 4 that memory location, 8 is stored in 5 indexed memory location. So this is how all the 6 elements, they will be stored in the 6 reserved memory location. So this is a single dimensional array. All are treated as one row here, we can say. Memory location is identified by array name and index. So what is this location? Array name is A. Its index is 3. So what is the value of that? 3. Okay. So what is in this memory location? That is 3. So which is this memory location? So array name A. What is its index? 5. So any memory location if you take here, that is identified by single index. So such array are called as single dimensional array. Okay. Next consider array initialization. So array name is A here. It is going to store integer type of values. So how many rows are here? 2 rows. How many columns are here? 3 columns. So these are row elements. These are another row elements. This belongs to first row. So this belongs to second row. So within flower brackets they will be specified. Then this is separator. That is between 2 rows, comma is a separator. So this is begin and this is end of whole data structure. This is end of instruction. So instruction is from here to here. It should be typed in single line. So int space A in bracket 2, then in bracket 3 equal to flower brackets. This is flower bracket. So one more flower bracket. Within one set of flower bracket, first row elements are specified. Then comma. Within another set of flower brackets, second row elements are specified. So this is end of structure, end of instruction. So in this way, if we declare and initialize, means assign the values. So if we declare like this, then also 6 memory locations will be reserved in the memory. So what is this whole block name? A, because A we have given. How many? So 2 rows, 3 columns means totally 6 elements are going to be stored. Hence 6 memory locations are reserved. But index of each memory location is specified by 2 index now. So what is the index of first memory location? So 0 row, 0 column. What is the second one? 0 row, first column. What is the third one? 0 row, third column. So third column means index is 2. Second column means index is 1. First column means index is 0. So these are the index of first, second, third memory location. That is what is this is indicating. Within one set of 1, 4, 2 are written. That 3 is specifying number of columns in each row. There are 2 rows, 3 columns. So 2 rows, 3 columns. Okay. So this is one column, second column, third column. Its index is 0, 1, 2. So first 0th row, second 1 row. So 2 rows means numbering is 0, 1. 3 columns means numbering is 0, 1, 2. Now what the index of this memory location? So this was first row. This is second row. First row index is 0. Second row index is 1. So in that first column means index is 0. In that second column means index is 1. In that Third column means index is 2. Hence, for this row, it is second row means row is 1. First column means index is 0. So this is row index, this is column index. So it falls in second row means index is 1. It falls in first column means index is 0. So this is A of 1 0. That is what is this memory location. What about this? So it also belongs to A array. It is in second row, hence index is 1. It is in 1, 2, 3, third column. Column means index 2. Okay. So A of 1, 2 means this memory location. So this is how two-dimensional array can be declared, or it can be initialized with the values. Then how the memory locations are allocated and how the data are stored in that. So this is what is required for writing a Java program for matrix addition using arrays. So here data structure used is arrays only, but it is two-dimensional array. Okay. So two-dimensional array means the array data structure in which each memory location has to be accessed with two index, right? Next, we shall see to the approach needed for the implementation. So the first step is take two matrices to be added. Then create a new matrix to store the sum of the two matrices. Traverse each element of the two matrices, add them, and store the sum in a new matrix at the corresponding index. Print the final new matrix. Okay. So these are the steps involved in the approach. So here the program is running NetBeans IDE. The name of program is matrix addition.java. So that is what is the name given here. Okay. And this is the output. 2 rows and 3 columns. When 2 rows, 3 columns of A are corresponding elements are added with that of B, this is the C matrix content where sum each time is stored. Okay. So this is the program in Java for matrix addition implementation. So program starts from here, it ends here. Okay. The first statement is package space BCS406. So it is created in this package. So public class matrix addition, this is the name of program. This is begin of the program, this is end of the program. In that public static void main, this is the main function which will be having the code. So this is the comment to do code application logic here. Application means here the program for matrix addition. So that is what is next written. So system.out.println, this heading is written matrix addition. So the variables are declared here int type. Which variables are taken? I, J, M, N. M for 2 rows, N for 3 columns. I and J, they are used as index in for loop. That is for traversing through each element of the matrix while doing addition and while printing the result. So this is A matrix initialization. A, here square bracket open complete, square bracket open complete. Nothing is there inside. Means whatever size we give, that size it will take there. So here we are giving 2 rows and in each 3 elements, that is 3 columns. So here the size of row will be 2 and size of column will be 3 here. Then totally 6 elements as a 2 by 3 matrix, and B also same thing. So here A is initialized with first row elements 1, 4, 2, second row elements 3, 6, 8. So B is initialized with 3, 5, 6 and second row elements 7, 2, 4. So C is also declared and initialized having 0 values for all the 6 memory locations. So first row 3 elements and second row 3 elements. Next execution of this for block. Okay, so nested for loop we have here. One for loop inside another for loop. So nesting of for loops we are using. So that is used for addition of two matrices and keeping the answer in third matrix. First I is made 0. So I is 0. So j is made 0 first time. So then C of ij means 0 0 equal to A of 0 0 plus B of 0 0. That is first row first column element of A is added with that of B and it is stored in corresponding memory location of C. After this the control will come back to inner loop. J is incremented, it is made 1. So J is made 1. So I is still 0. So C of 0 1 is equal to A of 0 1 plus B of 0 1. That is first row second element. Similarly next time second row third element because J is made 2. So next time J is incremented, it is made 3. 3 is not less than 3. So J is keeping track of column index. So 3 columns are there. So for 3 columns the index will be 0, 1, 2. Now it has become 3. So greater than this. So n is 3 here. J has to be from 0, 1, 2 means less than 3 it is. Okay. It has to be less than 3. J less than n means J less than 3. But it is 3. Hence it is false. So it comes out of this for loop and it goes to outer loop. Okay. Here. Hence the control will go back to the first one. So then I is made 1. Okay. So when it starts from here, I is 1. Again J will be 0. So 1 0 here. A of 1 0 is added with B of 1 0. That is second row first column element. When added, it is stored in corresponding memory location of C. So control will come back. J is made 1. So I is 1 now. So now 1 1. C of 1 1 is equal to A of 1 1 plus B of 1 1. That is second row second column element. So after addition it is kept into corresponding memory location of C. Then it comes back here. J is made 2. Right. So I is 1 only. So C of 1 2 is equal to A of 1 2 plus B of 1 2. That is second row third column element of A is added with B and it is stored in corresponding location of C. Next J when comes back it is made 3. It is not less than this. It will come back here. I is incremented. I is this time it is made 2. Okay. So now I is not less than M. It is not less than 2. Hence control will come out of nested for loop. So processing is over. The addition work is over. So next same kind of nested for loop is taken because of which we can go through every row and column element in A and print it. So this is print statement. Every element of C is printed. Then after printing one space is left. This inner loop is for printing first row all the 3 column elements. Then row is incremented. Again second row all the 3 column elements. This gives all the column elements. This gives all the rows. So for each row all the column elements. They will be printed on the screen. When every element is printed, the space is left. So after printing one row, that line is left. Then again 3 elements are printed. So before this, here one heading we have given, that is system.out.println. This function will print this heading. That heading will be here. So in this manner the output is this way. Matrix addition. So that heading, after that both the rows and 3 column elements of C are printed here because C we are mentioning here. Okay. So this is the output of program. So what is this? This is the heading what we have mentioned in the program by system.out.println. Next, this 4, that is first row first column element of A, that is 1, is added with corresponding element of B, that is 3. 1 plus 3 is 4, that is stored in corresponding element of C, that is after processing we have got this 4 will be here. Similarly 4 plus 5, that will be 9. 2 plus 6, that is 8. So next row 3 plus 7, that is 10. 6 plus 2, that is 8. 8 plus 4, that is 12. So this is the output of the program, which is adding matrix A elements with B, and it is storing in C, which is displayed here. Okay. This is how this program works, and that is what is the implementation of matrix addition using Java programming language. I hope you understood. Thank you.